Hello, Eco343. Welcome back to my session on labor economics. Today I'm explaining labor demand, and specifically I'm going to talk about elasticity of labor demand and how it depends on your output function, your production function as well. So, first of all, you have, let's say here, this is a random isoquant that you have here for different outputs that are constant along the isoquant. We know that the elasticity of labor demand holding y constant, so for here, depends on the shape of an isoquant. So an isoquant, just to recall, is a curve that maps out all combinations of G and U to produce giving a specific level of output. Okay, so the first scenario we're taking is for two inputs of a production that are perfect substitutes. So U and G are perfect substitutes. Your production function would look something like alpha times U plus beta times G. Given an output of y0 constant, the isocost slope for this specific function would be something like Wg over Wu is equal to beta over alpha. We noticed in this case that the isocost coincides with the isoquant. It's parallel to it as well. I shouldn't add anything else to this about perfect substitutes. This is how it should be then. That's how you solve for perfect substitutes. And the perfect substitutes leads to perfectly elastic labor demand when firms are currently indifferent between hiring G or U. So, in the case of having fixed proportions production function, which is here, where your production function looks something like minimum of alpha U comma beta G, in that case, your production your isoquant would be perpendicular to your isocost, and in this case, the production function leads to perfectly inelastic demand for G, holding y constant, because as much as you might use of U, you still need to use a proportionate amount of G, no matter who is more or less expensive. Okay. Lastly, I'm going to explain the most common production function, which is the Cobb-Douglas production function, which is y is equal to U to the power of alpha times Z to the power of 1 minus alpha. So you have your isoquant here, which is a curve that's concave, and you have your isocost, which is, and this is the point here. So your isocost, your Cobb-Douglas production function have elasticity of labor demand holding the y constant equal to, so for the input G, you have the elasticity of labor demand is equal to 1 minus alpha. But negative, of course, because we know already that the labor demand curve is always sloping down. Lastly, now, what if we stop holding y constant? How will the elasticity of labor demand change in this case? Well, for example, pause here.